domain-based VPN. In this nugget, we're going to take a look at our first site-to-site VPN option, which is going to be a domain-based VPN, which is going to be based on an encryption domain to control the routing through that particular VPN. So we're going to look at what makes a VPN domain-based, and then we're going to look at some domain-based VPN concepts, and then we're going to get into the actual domain-based VPN configuration to help you understand exactly how to set this up in your own environment. So I really enjoy this particular nugget, and this is going to be the building block of where we're going to be going throughout this series for VPN technology. So take some great notes and follow along, and let's get started. Okay everyone, in our previous nugget we learned about the concept of using encryption in our networks. Why it is very important that we do this to make sure that we encrypt our data and make sure it's just nice and secure for any data that leaves our company and goes across the internet. We definitely want to make sure that we're encrypting that data just to make sure if there's anybody sitting in the middle watching that type of information across the public internet, they can't get us. But now that we have that knowledge base behind us, let's dive into Smart Dashboard, and we're going to configure a site-to-site VPN between our Nugget cluster, which is our central site where our corporate office would be, for example, and our remote site where Nugget Firewall B is, representing one of our branch offices. So let's go ahead and dive into Smart Dashboard, and we're going to go ahead and log in here and authenticate. And once we get into Smart Dashboard, it's telling me that I'm already connected here. I'm going to go ahead and just tell it to do a disconnect and give me control of it, because I already had it opened here at the bottom. And that's one of the great things and a point to remember back to your CCSA studies as well, that only one administrator can have read-write access to the Smart Dashboard console at once. So what it'll say here, it just says that the server was disconnected, and it disconnected at one session. Alright, so where do we start at? Well, one of the first things we're going to do in review is we want to dive into each one of our firewalls that are going to participate in this site-to-site VPN and do a check to make sure things are set up as they should be. So let's start with Nugget Cluster. We're going to open this up, and if we go to our VPN tab here, we notice this module, it says this module participates in the following VPN communities. Now we don't see anything right here for now. We're going to add this particular Nugget cluster into a VPN community, but we're going to do it from our VPN tab. But we see this option available. One of the first things you want to do is to make sure that your certificate that's on this particular firewall is valid and is going to be for some time. And you can also renew a certificate from here, and you could remove it, or you could add an additional certificate, which we'll get into when we build a site-to-site VPN using a remote certificate authority from another firewall instance. And we'll take a look at that on how we can build a site-to-site VPN using certificates that maybe you get from another company or a vendor or something. So that's a pretty cool option as well, and I know you're really going to like that. So what we're going to do now is go ahead and expand this VPN area, and the first thing we need to look at is our VPN advanced options here. For VPN tunnel sharing, we want to control the number of VPN tunnels open between the peer gateways using our community settings. Now we could do some custom settings, and we can see here that we can do one VPN tunnel per host. So if we have hosts on each side of the tunnels, every time those particular hosts want to talk, it's going to do another security association to create that VPN tunnel. And if you have thousands of hosts behind each one of your firewalls, this can be, quite resource intensive. It may cause you some problems. The most recommended one that I use quite a bit is the one VPN tunnel per gateway pair. It's basically going to form a tunnel between two of the firewalls, or we have the option of one VPN tunnel per subnet pair. So if you have a subnet on each side of the firewalls, like we will, which will be a /24 subnet, you could do it this way as well. But for now, we're going to go ahead and set this on Use Our Community Settings, and let's look at some additional options on this page. we always want to make sure that this option is checked to perform an organized shutdown of tunnels upon gateway restart. So if you bounce your Nugget cluster, for example, for maintenance or for some kind of type of network change, you want to make sure that it gracefully shuts down that VPN tunnel so it doesn't mess up some of your settings or cause undesired results. And then we see the option here for wire mode. So what is wire mode all about? Wire mode is going to give you the ability to send uninspected encrypted traffic across a VPN tunnel to a trusted site. So maybe you have a backup site for your disaster recovery efforts. You can set up a wire mode connection, and that would allow that type of traffic just to be trusted as it was a site to site, or maybe a T1 to T1 connection, known as a T1 bond between your main site and a remote office. It's no different than subscribing a line from AT&T or Quest or XO Communications or any of the ISPs out there, and just saying, hey, I need a point-to-point site from this office to this office over a T1, and set it up. And that's essentially what we're going to do with wire mode, is we're setting up that point-to-point connection, but we're not going to go through the process of having to inspect that traffic every time with our firewall security policy. But that's the main thing about wire mode. Do remember that the main thing that you need to know about this particular option is it's going to allow uninspected encrypted traffic in a VPN routing configuration. And that's the main thing about it. And the last thing we're going to see on this page is NAT traversal, which is an industry standard as stated here, and it's sometimes referred to as NAT-T. And it's going to support NAT traversal, and it's going to apply that to our remote access and our site-to-site connections. Now, the next thing that we need to look at is we need to take a look at link selection. Now, we already have this selected here. We have a few options here. If you set up your public IP address as your main address whenever you created your object here in the general properties, you could go with the option of using the main address. What I particularly do most of the time, and what I see most customers do, is they'll use this option of selected address from the topology table. And if we hit our topology table drop down, we can see we have the option of using our external IP, which what we'll use, or our internal IP. We're going to use our external for now, so we'll set that to our 172.20.20.2, and that looks good. So now we have a few options here where we could calculate our IP based on network topology. We could use DNS resolving if we were going to use host names for resolving our link selection options. And we can use a probing method, which is going to look out for particular interfaces every so often. Let's turn that on and go to configure here. And this is basically what it's saying. It is probe all addresses that are defined in our topology tab, or we can probe the following addresses. If we turn that on, we can tell it to retrieve addresses from our topology tab, and it's going to give us the option where every so often it's going to poll either one of our interfaces on our firewall in order to be able to form a VPN. Maybe you have a firewall with multiple internet circuits on it, and you have multiple public IPs on that particular firewall. Using the probing method, it could look for those multiple public segments as possible options for setting up VPNs to. And that's basically what the probing is all about. So let's go ahead and cancel out of here for now. We're not going to use that, but I wanted you to see that option and let you know that is available for doing our link selection. But what we're going to do is go ahead and put on always use this IP address, and we're going to use our 172.20.20.2. And on this option, once we get down toward the bottom, we see our outgoing route selection. And I typically just leave this one, and it says operating systems routing table. You're going to be in great shape 99% of the time. If you want to do route-based probing, you could do that type of things as well. If you wanted to be able to look at some different options. But let's just see here. If we set this up on route-based probing, every so often it's going to go out just like the probing method for looking for interfaces. It's going to do the same thing with your routing table on your gateways. It's going to use a probing method and see that maybe you have a better path that changes every so often if you're using a dynamic routing protocol such as OSPF or BGP or something. Maybe if something changes dynamically in your environment, you may have a better path going over that routing protocol to get to your remote site. But for us, we're going to tell it to use our operating system's routing table, and we'll be good for now. And on tracking here, for outgoing link tracking, always hit this and set it on log. And that's the main thing that we need to take care of in the link selection area as well. So that's pretty much mainly what we need to have set up. Let's look at a couple other options. Under topology, we have our VPN domain. So what is our VPN domain all about? Our VPN domain is going to be referred to sometimes as our encryption domain. Our encryption domain is going to be the interesting traffic that is going to be encrypted across our VPN sites. And whatever you have in this box right here is what's going to be encrypted. By default, it's going to be on all IP addresses behind the cluster members based on the topology information. So maybe you have a particular internal interface here that's a /16, and you have quite a bit of IP addresses and subnets that are behind your firewall, and you want to be able to encrypt all of that going toward your remote site and have it available to go through the VPN. You could use this option where it's stating to use all IP addresses behind our cluster member based on our topology information. But if you want to control exactly what's going through and what you trust to travel from your corporate site to your remote site in a VPN tunnel, you're going to want to control that with a manually defined encryption domain. And that's what we're going to do. We're going to state that our internal subnet, the 10.20.1.0 in this case, is going to be part of our VPN domain, and it's going to be our interesting traffic, stating that whenever we send packets across our VPN tunnel and we see that it's from a 10.20.1.0 network, go ahead and encrypt that packet, because we know it needs to be encrypted to travel across the site to site to our Nugget Firewall B, for example. So we have that in place. We're in good shape. Now, once we have our topology, we went through all of our VPN selections, all that looks great. The next thing that we want to check out is going into our actual communities and verifying that everything's working as we would like it to be. So, that looks fine. Let's go ahead and hit OK. Let's do a quick verification to run through some things on Nugget Firewall B just to make sure it's set up the way we want it. We have VPN turned on this option right here. And again, that's something else you're going to want to check on your Nugget cluster as well. Otherwise, VPN isn't going to work at all. And so once we have that checked, we're going to go through the other options that we just saw. For our VPN domain, we have our internal subnet of 10.20.30 defined on our Nugget Firewall B, so we're in good shape there. And under VPN Advanced, we're going to tell it to use our community settings, perform our organized shutdown, support NAT-T, link selection, we're going to have it use our external IP of our .30, and we're going to use our operating system's routing table, and outgoing link tracking, we're definitely going to log that as well. So we're in good shape there. So we'll hit OK, and now we'll select our VPN tab here, and we're going to build our community. Alright, so under our VPN tab, we're going to build a new community to represent our Nugget Lab. This is the standard ones that we see for remote access and for My Intranet. My Intranet is going to be representing a star configuration or a mesh configuration, stating that no matter which one of the gateways in this particular configuration was to go down, if you have an alternative path to get to the VPN community through another gateway, you could do that using a star community like this in My Intranet. And that's what we're going to do as well, but I want to kind of build our own, so we're going to delete this for now. We're going to remove this one, we're going to tell it new community, and we're going to set this up where we're going to do a mesh community, but we're going to call this one the Nugget Mesh. Alright, looks good. Alright, and we're going to set our color. We'll go green on that. And we have a few options here, and let's talk about those. On this particular screen, we see an option for accept all encrypted traffic. And if we do this, what it's going to do, instead of us giving a chance, you'll see in a few minutes where we can set up a VPN rule inside of our security rule base to control what type of traffic goes into our VPN communication. All encrypted traffic is just going to be accepted by default. So you won't get the option to filter down exactly what type of protocols or what hosts get to use the VPN essentially. And we'll see that option in a few minutes as well. As you notice right here, it says this rule applies for all internally managed community members and log traffic as defined in the Global Properties Logging tab to log. So it's pretty self-explanatory, and that makes sense there. And I just want to show you basically what this is all about. And just so you'll see real quick, we'll just tell it to accept all encrypted traffic, hit OK. And if we notice here on our Nugget Mesh, if we go back to security, what do we have right here? Accept VPN traffic rule configured from the community. So the destination on the member gateways for the Nugget Mesh encrypted services, accept everything, and that's essentially what that will do. Now we're going to be able to build our own VPN rule, and we can control exactly what's going through our VPN, but that's what that option does, and I wanted you to see that. So let's go back to VPN, open up our Nugget Mesh, kill that option, and let's go through and build our VPN. So under our participating gateways, let's go ahead and do add, and we're going to put both of these particular members in here. So we can hit control and highlight both of these. Hit OK, and that's going to put our Nugget cluster and our Nugget firewall B in. We'll go into our VPN properties. And what do we see here? We see our IKE Phase 1 and our IPsec Phase 2. So if you remember from our previous Nugget where we discussed what goes into building a VPN, this is what it takes. We could have a two-phase authentication process where we're going to be able to do our IKE Phase 1, establish an SA there, do our IKE Phase 2, get our SA information there, and be able to build our VPN. Now we have our options here, and as you know, we have many options for configuring the type of encryption option that we want to do, and we can perform our data integrity with different options. We're going to state basically that we want this community to be as secure as possible. So we're going to do AES 256, and this is basically the latest standards for the Federal Information Processing Standards, or FIPS as it sometimes is called. And we're going to actually do AES 256, and we're going to apply that type of option. And we're going to, in this case, we could do an MD5 or we can do a SHA-1. So we're just going to go ahead and do a MD5 for now, and we're going to do MD5 on both of them, and we're going to perform both of them on AES 256 with MD5. So we'll do that for now. Now we can change this type of information up and get a little bit better security using the different options, but we're just going to use this for now, and then we're going to go into our tunnel management. And the main thing to remember about this whole options of our Phase 1 and Phase 2 in review, this is where you can control each one of the protocols. Make sure you understand what triple does this, what are the parameters that it is used for, what the AES 128, AES 256, DES, and CAST can do for you, and just understand what these protocols are about, and you'll be in good shape, not only for your CCSE objectives, but for your career in network security. Alright, so we're in good shape. And we have that, looks good. Let's go to tunnel management. Now we have an option right here where we can set permanent tunnels, and what this is going to say on all tunnels in the community, and what this basically is a keep alive. It's going to set up a keep alive process that says, you know, no matter what happens, make sure these tunnels stay up. And for us, we're going to go ahead and use that option. We're going to tell it to set permanent tunnels on all tunnels in our community, and we're going to want it to use that type of option to keep that tunnel up and going for us. We also have the option for on all tunnels for specific gateways. Maybe you have a critical gateway site you want to stay up only, or on specific tunnels in the community. But we're going to do all tunnels in the community. Alright? And then we have an option here for Enable Route Injection Mechanism, or RIM. If we wanted to set this and go into Settings, we can enable Automatic Route Injection Mechanism, and where we can enable Custom Editable Script Execution. So if we needed to use a dynamic routing protocol to be injected inside of our VPN community, we have that option available as well from our community settings. But we're not going to be doing that in this settings, and I really haven't seen that done in a lot of environments, but the option is there if you need to use it. So we're going to go ahead and turn that off for now, and we're going to tell it to use the default here is going to be 1 VPN tunnel per subnet pair, or we could do the 1 VPN tunnel per gateway pair. We'll just keep it on the default for now and go to our advanced settings. Under our advanced settings, we have a few options here. We have excluded services. Now, what is excluded services all about? It's the information that you need to be sent in the clear to make sure that you have basic communication without it being encrypted. Some protocols will cause you a problem or basically just not work properly through a checkpoint security policy if you need it to go unencrypted. Maybe you want to be able to do a ping or a HTTPS to the 1980 port or something like that to get to the website that's running on your splat box, and you don't want that type of information encrypted or sent across your VPN tunnel. This is where you would exclude that type of information. And if we just go through the basic description right here, it's going to say the following services are excluded from the community. Connections with these services will not be encrypted and will not match rules specifying the community in the VPN column. So if you needed to set some options, like I basically stated for 1980 or any of the other ports or protocols, and you don't want it encrypted or sent across the VPN, but you may need it for some type of management of your checkpoint firewalls, you just throw it in this particular box. It won't be injected into the VPN and you'll be in good shape. Now, under shared secret here, we're going to look at this where we're going to set up an actual VPN at some point where you can set up a actual shared secret between your gateway members. Where you would typically use this is for your remote vendors. Maybe you have someone out there that's running a checkpoint firewall or a Cisco device or a Juniper device or anything like that, and you need to form a VPN with that partner or that vendor to get some data between your company and their company. Typically what most people do today, they will form a shared secret to allow that actual VPN to take place. Now, basically what you want to do is you definitely want to make sure that you always transfer that shared secret in a secure manner. Usually I recommend doing that over a private phone call or encrypting something on a USB drive, and you guys actually FedExing those overnight between each other, just to make sure that the shared secret information is held. And I do recommend using a pretty long security key, maybe like 10-12 characters if possible, and make sure that you put in some special characters as well if you're going to be forming VPNs with vendors out in the world. But for your checkpoint studies, you know where it is, you know what you could use it for, and that's the main thing we need to know about our shared secret option. Now, under advanced VPN properties, this is where we can get in to say with our IKE Phase 1, we want it to use the following Diffie-Hellman groups. Now, Diffie-Hellman groups, as we talked about in our previous nugget on encryption, is going to give us a little bit better security in our whole algorithm, depending on the size of the group that we choose. As we can see here, we have group 1, Group 14, Group 2, and Group 5 for our Ike Phase 1. I tend to leave this at its default values of 1024 bits, and that'll be fine for now. We can renegotiate our actual Ike Security Association every 1440 minutes. That's fine with me as well. We can use the aggressive mode option that we talked about for setting up that Ike process. We could use our perfect forward secrecy, and we can renegotiate our IPsec Security Association every hour or 3600 seconds, and that's a good option to leave all these things in place here. And we also have the option to disable NAT inside the VPN community. So if you have some NAT rules in your security policy that are being applied and you don't want that type of NAT to take place whenever you're trying to go to your remote office or your branch office, you can choose this option right here to disable NAT inside the VPN community, and you'll be in good shape. And you'll be able to verify inside of your SmartView tracker if things are getting NATed when they shouldn't be. You just open up the packet, it's going to show you the source, and it's going to show you the actual NAT information, just like it would whenever you're going out to the internet, for example. And just so we can do a quick review on that, let's go ahead and from this particular option right here, let's go out and ping yahoo.com. Alright, so we got a ping out, and from this window, let's do window SmartView Tracker, and from SmartView Tracker, we'll jump down and take a look at those packets. Alright, so looks pretty good here going out to Yahoo. And if we see right here, we can see all the additional, if we do more information, we could see that Nugget PCA made a ping out here, and if we wanted to see the additional information about the XLate options for NAT and all that, that's where you would jump over to your options up here under our query properties and turn on our XLate information. And this is kind of a review, I know, for a lot of you from your CCSA studies, but when you're getting into securing your data and managing a security policy on a daily basis, having complete vision into what every single packet is doing on your network is going to be really valuable. And at some point you may need to defend your network and your configurations, stating that, you know, this is the way that we configured it and this is the way that it's working, because you're going to be in a situation at some point when things aren't working right. It's going to fall back to the network security team and the network operations team to A, either resolve the problem, or B, make sure that it's not their problem. So now that we had that particular option in place, we could hit our drop down at this point, and we can go out and look at particular packets and different things like that. And we're going to see that we have an XLate port, our XLate destination, and our XLate source, and different things like that. But that's the main thing to understand. Like this particular host, it has a static NAT on it. So this particular host is a 10.20.1.22, but it's natted out to the public IP on 22. But we have those options in place. You understand that. Let's jump back over to dashboard and let's continue on with our overall discussion on what we can do inside of our VPN community. So we have our advanced VPN properties. We talked about all of our advanced properties, and here we see our wire mode options that we also talked about, where we can do our uninspected encrypted traffic. Alright, so let's get everything configured. So we have our participating gateways. Let's go ahead and add our guys in there. Make sure we get them in there all the way for Nugget Cluster and Nugget Firewall B. We'll hit OK. That's in place. We're in great shape there. VPN properties. Let's go with the setup here, where we'll go ahead and we could do the MD5 or we could do the SHA-1. Let's go ahead and accept the MD5 option, and we're going to do AES 256, and we'll go with that for now. So let's go ahead and hit OK here. Let's save this particular policy, and now that we save that, what do we see? We see a nice graphical depiction here stating that there's going to be a firewall VPN between Nugget Cluster and Nugget Firewall B. And as you highlight it, you're going to see that the VPN domain states that it's manually defined, and it's going to show you what's in the encryption domain. So that's some pretty cool options for sure. And it's going to tell you some information about your algorithm, your integrity, and your renegotiation time for this particular tunnel. So now that you have that in place, go ahead and save this and go back to our security policy. Now, our security policy, we see this rule about accepting VPN traffic configured from the community and all that. Let's verify that we don't have that turned on, because we're going to want to control things from our own setup. So let's turn it off there, hit OK, go back to our security policy, and now under our actual setup here, for our firewall management and things, we're going to need to be able to set up an actual VPN rule that's going to state what's going to go through our VPN. So what I like to do is, normally under my stealth rule, I will apply my VPN rule. So we'll do rules, add rule below, and we're going to call this one S2S VPN, because it's the site-to-site VPN for us. Okay, now source, it can be any, destinations, any in this situation. VPN. The VPN column is where we need to lock things down. So we'll go edit cell. We'll do only connections encrypted in a specific VPN community. We have some other options here. And encrypted in any site-to-site VPN, or any connections, whether clear or encrypted. We can put those type of information in. But what we're going to do is we're going to kind of lock it down. We're going to say that only things that are part of our Nugget Mesh community are going to be part of this. We're going to accept that packet. We're going to definitely make sure we log it. And we're going to install toward our policy targets, because we're locking everything down under our policy installation targets right here. Alright, looks good. Now that we have that in place, we have our site-to-site VPN. Let's go ahead and do a quick save. We're going to do a policy verify. Go ahead and verify our security and address translation rules on this policy. Looks good. Go ahead and do a policy install. We're going to push this out to our Nugget cluster, and then we need to do the same thing to our Nugget Firewall B to form that VPN between our two sites, where our users from our internal subnet behind Nugget cluster can talk to users that are behind Nugget Firewall B and their internal subnet. So that installation completed successfully. We're in good shape. Go ahead and close that. We'll get all of this minimized. We'll save this particular policy, and we'll go to File, Open up Firewall Policy B, and as we open that up, we'll go ahead and save this. And the good thing to remember, ever so often, whenever you're actually pushing a policy or any kind of major change, you may want to turn on the option that it creates a database revision control for you before it pushes those type of policies. And that's just a good way to cover your bases. And we'll look at that, and we're going to do that in this particular case as well. So under our remote VPN, we had our SSL VPN that we talked about in one of our previous nuggets, where we got SSL network extender deployed to our Nugget Firewall B, so our remote users don't have to run home to take care of business. We're actually going to add another rule right below this for our site-to-site VPN. So we'll do add rule below, and this is going to be our site-to-site. So we're going to do S2S space VPN. Looks good. Same type of setup here on the VPN. Edit cell. Only connections in this community. Nugget Mesh. Okay. Looks good. Let's accept that. Let's definitely go ahead and log that type of information. And we're going to put that on our policy targets as well. So we're in good shape there. Now we'll save this particular policy. Go ahead and do a policy install. We're going to turn on and create the database revision control, just to make sure that we have a snapshot of what's going on. It tells us that the version was created successfully, and now we're going to go ahead and push this policy out, and this should get our VPN up between our two sites. So users at our Nugget cluster site and our Nugget Firewall B site can talk to each other, and we're one big happy family in our company. So let's close off of this. And now let's do some quick verification. Later on in the future Nugget, we're going to dive in looking at some command line options. But let's just see GUI based. How do we know if this VPN is up? In most cases, and we're going to explain one additional value that we're going to see here, where let's go ahead and just clear this particular screen, and let's see at this point what we can see in our network. So let's go ahead and do a window Smart View Monitor. We're going to use our GUI tool here and verify, do we see any type of VPNs between our guys here. Now, as of right now, from Nugget Firewall B, if we refresh this, it says gateway to gateway tunnels, and we don't have anything in place here. So how do we form our VPN? That interesting traffic that we talked about needs to be initiated from behind either one of the firewalls. So in this particular case, what we're going to do is just try to ping over to something behind our cluster firewall from our Nugget firewall. So what we're going to do is go ahead and just jump out to our desktop here and jump on to PuTTY, and we're going to go ahead and PuTTY over to our Nugget Firewall B, which is going to be 172.20.20.30. I'm sorry, that's actually 172.20.20.30 should get the job done for us. So let's go ahead and connect over. Let's do some quick verification, making sure that we're going to the right place. Alright, 172.20.20.30. Okay, we should be in good shape. Alright, so let's use our PuTTY to do 172.20.20.30. Go ahead and load that up, open that up at this particular time, and let's just see what we get in Tracker. More than likely what it's trying to do is we're seeing some type of encryption options trying to happen here, and that's why things aren't looking the way they should be. So let's go ahead and under our edit option here, let's turn off our query under our view, and then let's go to the bottom of our tracker here, and what do we see? We already have packets attempting to go across. So let's start looking at the packets here. We open up the first one here. We have the key install. It says resolved IP for tunnel, Nugget cluster to Nugget Firewall B, 172.20.20.30 primary IP. We go next. We're gonna always see a main mode completion. That's the first process of our VPN. Then we're gonna see main mode where it's talking about our particular subnets that we want to talk to. Looks good. And then we see our actual encrypted packet. We see that from our Nugget PCA, we tried to talk to Nugget Firewall B over TCP SSH version 2 on port 22, and it tried to encrypt that packet, and we see the key install process from the source being Nugget cluster to Nugget Firewall B again, and then it says resolve the IP for 172.20.20.2. And the origin here, if you notice, is Nugget Firewall B. So it's trying to get the actual tunnel formed between the two firewalls. Say, for example, Nugget Firewall B again. Quick mode completion, so that's the second phase of this option, where it's negotiating its tunnel based on its host information behind Nugget Firewall B. Alright, so why didn't it work? What do we see here? Encryption failure. According to the policy, the packet should have not been decrypted, is what it's saying. So, basically what we saw there is we saw an option where it dropped the packet. And now I want you to see this because this is a common error message that you may see from time to time, that you need to manage your firewalls, and this talks about that whole encrypted process of excluded services. So let's go ahead and take a look at that. We're going to set up port 22 to be excluded to state that, hey, I want to go across my internet circuit in the clear and I want to talk to my firewall on the remote side, but I don't want you to try to encrypt that type of packet. And that's where we're going to use the excluded services to use port 22. So let's go ahead and go out to our particular community here, open this up, open up our Nugget Mesh, open up Advanced Services, our Advanced Settings, go to Excluded Services, and add our SSH here. Alright, SSH version 2, looks good. Put that in, hit OK. Do our policy install, and we don't need to do a particular database revision. Let's go ahead and hit OK here, and we're going to push this policy out to Nugget Firewall B, and we'll do the same thing to our cluster policy as well. And once we get those type of information pushed out and delivered to those firewalls, we'll be able to successfully connect to that firewall using port 22 for SSH. So let's go ahead and do File Open, open up our standard policy which controls our cluster, do a policy install, push that out as well, and then we'll be able to do our verification. But you understand the point there that whenever you need to manage your remote firewalls, if there's a particular protocol that you want to use, such as a ping or a HTTP web connection, like we're using port 1980 or SSH, for example, to manage that firewall, if it's not excluded from the community, it's going to try to encrypt that packet. And as we saw in Tracker, we had an error message and the connection died on us. So let's close off of here for now. Let's save this, and now we'll go back to PuTTY, and we should be able to form that connection over to that firewall. So let's try our verification again of getting over to our Nugget Firewall B via SSH. Alright, 172.20.30. Open that up. Alright, still didn't work for us. Let's go back to Tracker here and see what we're getting. Alright, we see this packet leaving our PCA on SSH version 2, but we can tell right here on Nugget Firewall B, it's arriving as SSH. So it looks like that policy isn't being allowed. So let's go take a look at that particular policy. Make sure we're on, okay, so we're on Nugget Firewall B policy. Under Firewall Management, okay, we only have SSH version 2 here, which is typically what we want to use, but this particular PuTTY option being accepted by this particular firewall is using that protocol. So let's add that in and type in SSH. Alright, looks good. And what else did we see here? It sees it as its NATed IP. So let's take a look at that as well. Now, what do we have here? We have our Nugget Management Server, which is on the 1020.1.20. And we have our Nugget PCA, which is here with a NAT over to 172.20.22. So, what it looks like at this point is from the Nugget cluster, it's sending it out, and it's coming through, but this particular NAT for some reason isn't being honored, or it's not being seen because this particular NAT is only installed on our Nugget cluster. But the easy way to fix this is just to throw an object in here representing that public IP just for now, and let's get our process in place and verify our VPN. So we're going to do nodes, do a new node host. Let's try that again. Alright, and we're going to call this one NAT underscore host underscore A. Alright, and our IP will be 172.20.20.22. And we'll put that in place. Okay, looks good. Let's save that. Add this as a possible host in which that can use the SSH or the SSH version 2 with NAT host A. Looks good. Save that. And let's go ahead and push this out to this particular firewall, and then we'll try another verification here, and hopefully this will work for us so we can test our VPN back to the inside of that particular host, which is 10.20.1.22, and that's representing the internal host that we're on right now. So Now that we had an error, let's go ahead and right click here and tell it to restart that session for us. And let's just see what we get. Alright, success. So it actually connected for us that time, so we're in great shape there. Let's go ahead and log into this particular firewall. And once we log into it, then we'll be able to just do a quick verification from the B firewall coming back across the VPN tunnel and trying to hit something behind the cluster firewall, which is going to be something in the 10.20.1 network. And for example, we could try to hit our management server on its internal IP, which is the 1.20. So let's see what's going on with our actual login process here. And we should get an option here. I think I may have fat fingered our password, but give me 1 sec and we'll see what we get. And that's going to take a second to time out. We'll just kill it for now, and let's start us a new putty session and we'll do a verification. Alright, so we'll go 172.20.20.30. Looks good. Open that up and we should get a prompt here. Alright, let's log in. Alright, so great, we're logged in. We're on Nugget Firewall B, as we can see. Now let's see if we can reach our management server, 10.20.1.20. We can ping it. Wonderful. So, what we're going to see here, if we jump into Tracker and we scroll down, we see our actual verification process take place. Now, we can see that at this point, it actually ended up using our SSH version 2 anyway. So that was something that was just working a little bit weird there for a few minutes, where it was defaulting to this SSH protocol and getting dropped. But now we see everything's working as it should be, and it's using this particular host with its internal NAT. So that may be something that could be that you may see at some point, but just be aware of it. So what we see here is we see the key install process happen, and we see from Nugget Firewall B to our Nugget Management, we see the actual encrypted packet, and from our Nugget Firewall 1A, we see our decrypted packet. And what do we have? We have a full VPN connection there, and we can verify that by coming into our Nugget Firewall, refreshing that, and Nugget Firewall B and gateway to gateway tunnels is now 1 and 1. Click on more information and it'll give you a second. It'll show you your encrypted traffic, and it'll show you all active tunnels is 1 and 1. So there we have it. We now have a site-to-site VPN set up there, and we're in great shape to know that our users behind Nugget Firewall B can talk to our users behind the Nugget cluster and vice versa. So that's going to work out great for us. In this nugget, we cover the concept of a domain-based VPN, site-to-site VPN setup. We looked at exactly what's going to make a VPN domain based on its encryption domain, and then we looked at the domain-based VPN concepts, and we actually presented the actual configuration of this VPN to help you follow along and understand the concepts and be able to implement this in your own lab or in your own organization to get site-to-site communication between your branch office and a corporate office like we did in this particular nugget. I hope this has been informative for you, and I'd like to thank you for viewing.